Good morning, everyone, and good afternoon and good evening to people around the globe that are in the audience. My name is Mark Snedeker. I'm the SVP of Growth at D-Wave. Yesterday, we saw a number of companies come up and talk about how they were using D-Wave's technology to solve real-world problems, to drive value to their business. We're hoping that discussion inspired many of you to want to start your own quantum journey. And maybe you're wondering how you may do that or how you might build your own internal quantum capability. So today, this panel is designed to expose you to people who've been on that journey. And the panel varies in that some people are just at the beginning of building their own internal quantum journey. Others are a little more experienced to others who have been around the block a couple of times doing this in multiple organizations. So all of their insights are unique and interesting. And with that, I will hand it over to Brian.
Thank you. So my name is Brian W. Smith, and I am the lead software engineer for our quantum computing team at State Farm. And I've been with State Farm for now about 2 decades, and the last 8 of that within our innovation department, which we call labs. And the goal of labs is to, very much like other research areas, is to discover what's possible. The idea of where might we be in years' time frame, and what can we do today to prepare ourselves for that time frame. The last 3 years of that is essentially where I've been the engineer on our quantum team. So we started our quantum team in 2021, and the initial questions that we had to answer were, are we too early? Right? That's a question that all enterprises have to answer whenever there's some form of a new technology that comes out. So in order to answer that, we kind of focused in on who are the partners that we can ask this question of, right? Who can help guide us, kind of define what our roadmap might be. So very early in the process, it was discussing a lot with industry partners, whether that be vendors. Our venture area was also very involved in talking with startups that were involved in quantum computing. Ultimately, we decided, yes, there's definitely something here for us to dive into and definitely worth the investment to spin up a team. And so that's essentially where we get into 2022, where we started a small team of developers, primarily software developers and data analysts. And the question shifted into how do we actually experiment? And we like to define it as if the original start was talking about the partners and understanding what the industry looks like, the second phase was all about the platforms. What platforms are available, and that kind of dives into both the hardware, so gate annealing concepts, what other vendors are out there that we can actually run something, quantum workflow on, and the other aspect of it, which is, of course, software. What libraries are available, what sort of APIs are available out there, and how do you actually run a quantum workflow and integrate it into your enterprise that already has their workflows involved as well. So that was really what 2022 was for us. It was trying to learn and educate our team about how to incorporate this into an enterprise environment. So now we talk about 2023, and 2023 is a time where we get into that third P, which is the problem space. The problem space and trying to define what we're actually doing, why we're doing it, is probably the most important thing. A lot of times I wish we probably would have started some of that a little bit earlier, right? There's some lessons learned. But if your business doesn't have problems that you can address, first of all, you're not looking hard enough probably. But it doesn't matter how good the technology is at that point. So 2023 is where we're going to dive much harder into working with our different business areas to figure out what is feasible. It's also not good enough to just find a hard problem, because that's something that we hear all the time, is just find your hard problems. Because one hard problem to one area is completely different from a hard problem in another area. So our job on our team is trying to understand the technical and starting to do some of these experiments so that we have examples that we can show to our business areas, and then trying to understand that well enough and merge the two of them together. So some of the challenges that we've had so far and that we're working through, education is a very interesting one. State Farm, and especially our labs area, is very technical. We have a very robust resource pool for technical people, very skilled developers. However, we don't hire many physicists. And I sometimes joke that it's easier to teach a physicist how to program than it is a programmer physics. And so that was one of our challenges within the last year. Certainly personally for me, I haven't had to care about linear algebra in 20 years. And so that's one of the challenges, and one of the things that I've had to overcome is that education curve. Something related to that is we have primarily been dealing with gate technologies. So we have not been diving into annealing yet. So that's something that there's a different learning curve between these things. I also like to explain that a classic system, I've been a developer for a very long time. I've never had to care about the ones and zeros. I've never had to necessarily care what a transistor is doing. But when you're going through the process of learning gate technology, you do kind of have to understand that low level. You have to know what a qubit is doing and how you're actually manipulating it to develop your algorithms. And so that was a different adjustment for our team to have to deal with. The second problem that we're starting to deal with now is that problem identification piece that I mentioned. Because you have to be able to convince businesses that even if you can increase your productivity, they have to take everything into consideration. So are they going to have to hire new people who understand quantum? One of the issues is there's not enough abstraction between how to actually develop a quantum process and what a business is expecting with the classic system. So that's one of the things that we're running into right now. Someday it would be great if the only thing that exists are a few libraries and APIs, and it's as easy as changing a coding language or something along those lines. But at least for the experience that we've had so far with the examples that we had so far, that's not quite the case. So those are some of the issues that we've had recently and what we're looking forward to in the future.
Thank you, Brian.
Thank you.
Venkat, would you like to go?
Yep. Thank you. Morning, afternoon, and evening, everyone. I'm Venkat Kasirajan. I work for the Office of Technology, heading the quantum technologies research at Trimble. Basically, I am a physicist, but I took up software engineering as my profession. It exposed me a number of things. It gave me a good career, but physics is here. I am now returning back to my roots, exploring my connections with physics, with all the things that are happening in the quantum technologies. I'm a published author of a textbook on quantum computing, and I teach at some places too. When it comes to setting up a quantum team, being an author of a textbook, it has given me a number of avenues to explore things. One thing I've been really struggling is to find a good physicist who can also do some software engineering to a good degree. And that part has been very difficult for me to come across. However, I got one bright student who would do n-dimensional Hamiltonian math in his mind before you even write the math equation. But those people are really rare. I also tried to train classical developers to do some quantum stuff, but it didn't go that far. However, I had a different opportunity sometime in the past. I was working with one group that does visual odometry, point cloud processing, and perception computing in Trimble. Back there in Trimble, we serve a number of business cases. So I need to find which ones could really be successful, and how do we form the intersection of teams with expertise with the respective domain, with quantum computing, and also with some amount of web development, so on and so forth. So I had this opportunity to work with that group. I gave them a chapter from my second book, which is not yet published, that talks about optimization algorithms for quantum computing. After that introduction, I sent one of them to a D-Wave session, sort of a 2-day tutorial program sometime back. So after that tutorial, I found that person was able to really solve a 13-block bidirectional optimization problem for farmers. Quite a complex one. It's got about 4 trillion combinations. It could be one of those optimal solutions, but he was able to solve that in a couple of hackathon events to a very great accuracy, to my surprise. So when you form an actual team, you need to bring in the right domain expertise who knows the actual domain, a group of people who know quantum computing, and also a team member should be able to define the optimization problem and then write the actual math to do that. So once you do that, you can be really successful. That has been my journey so far.
Yeah, I think you can tell from Brian and Venkat's comments that I think a typical starting place for companies when they start their quantum journey is gate model. If you Google gate model, or maybe if you chat GBT quantum computing, you're going to get a lot of answers that are related to gate. And we work with a number of companies who've done the gate thing and maybe have realized if they want to add value to their business today, they also need to add annealing to their capabilities, so they pivot. And you hear a lot about maybe the difficulty of getting a physicist to do something different than physics. When you pivot to quantum annealing, the key resource is more of operations research or an optimization engineer or a data scientist or mathematician. That's the key skill to use our quantum computer. I think maybe it's a different bar or a different threshold to go over than it is for gate model. So with that, Florian, if you'd like to go.
Thank you, yes.
Yes.
My name is Florian Neukat. I'm Terra Quantum's Chief Product Officer. Before that, I spent almost 11 years with Volkswagen Group and was directing software innovation and IT strategy in the Advanced Technologies Group. And there we had the chance to build a great quantum computing team as well. So my academic background is also both physics and computer science, and I still work as a professor for quantum computing at University of Leiden. And I remember when we started at Volkswagen, the question was also, are gate model systems available? And is there anything we could use, anything that is industrially relevant already? And there wasn't. And then we found D-Wave, and we started this conversation with D-Wave, still wondering when is the time to start. And then we had this conversation, and I remember vividly we flew back home and knew now is the time. So, and that was 2015, 2016 when we started. And we were still thinking about a problem, because that's, in my point of view, the most crucial aspect. So still quantum chips, quantum systems, they keep maturing, they become more complex and are able to solve more complex problems in the future, will be able. But then it's always in the context of this time, when you look at it, when you start, what's the right problem to approach, to tackle? What can I solve today with these systems? And as a car company or mobility company, we thought traffic flow optimization would be great. It's a complex problem. Everyone knows traffic. No one likes traffic jams, as far as we know. And that's where we started. And D-Wave was also super excited about that problem, and we were thinking about this together, so how we could solve a smaller scale version of that problem. So back then in 2015, we didn't solve all the traffic problems in the world, but still we had a problem where you could show you can take some real world data. So it was real position data of vehicles that we collected, and then embed that on a quantum chip and solve this problem. And that really kicked off, at Volkswagen at least, the quantum computing journey. We started with a group of two, so one myself and the other one was Christian Seidel. But then the other challenge was there were not too many quantum computing specialists available in the market. So how to start? Do we need quantum computing specialists? And as we heard in the previous comments already, it's not required that you hire quantum physicists to do quantum computing. So it depends on what you want to do. If you're a quantum computing company, of course it makes sense. But if you want to solve problems, then I think the engineers that you have in your company, that's a good starting point. And that's how we started. So we grabbed the best engineers that we could find in our company, and then again, visited D-Wave for a couple trainings, and it was fairly easy to get going. And then over time, all of this matured. This matured into software solutions that were provided to solve traffic problems for cities, mobility platforms that would optimize fleets of vehicles, be that for taxi companies, be that for other fleet providers, distribution, delivery companies. It matured into systems that we develop for production, so for optimizing forklifts in production. If you think about a company such as Volkswagen, a mobility company back then, they had thousands of forklifts available, so how to optimize these? Maybe you don't need thousands, maybe hundreds is enough. And that's really all these things that we looked into, and then over time could mature that to solutions that were really practically useful and could be sold to potential customers as well. The other aspect that I want to emphasize on is even if you have a problem that's too complex to solve today, it still may be valuable to look at it as a company because of the IP that you can generate. So even if I can develop an algorithm today that solves me some downscaled version of a production problem that is of tremendous value for your company, it may make sense to look into this, develop an algorithm, secure the IP, and then once time is ripe, once systems are powerful enough, then you can solve it at full scale. So even here, the value is already given. So all in all, I think the most important aspect, at least to me, in this journey of bringing solutions into production was really start with whatever you have, with the engineers that you have at hand. It's not too complicated to educate skilled engineers to do quantum computing. And that's what I would encourage everyone to do, and think about the right problem in the context of the time that we are. So what's right today? What can these systems that we have to our avail today, what can they solve? And what is valuable to my company? I wouldn't even think about toy problems. So very often when we are in academia, we have to start with those problems that show there is show you can do something with a quantum computer that a classical computer cannot do, but then you question the practical value of it, and sometimes there is none. So I would really look into these things that have practical value today, and worst case, solve the downscaled version, but secure the IP.
Okay. Florian, I know you've done this at a couple of companies. For a starting capability within a company, how many people do you think is typical, or would you recommend people start with? How many resources?
So we started with 2, and that was totally fine. But of course, once things grew, it just matured to 15, 20, and depends on how many resources you have available. So it's always easier to say that. When I was at Volkswagen, our IT was 13,000 people. So if I add 15 or 20, it doesn't matter too much.
Yeah.
But if I have a smaller company with 100 people in IT, then it may be more challenging. And you may want to rely on an external solution provider, but I think it's always crucial to have people internally available that understand how technology works, no matter if it's quantum computing or another one. And then I think you can get going.
Okay. Thank you. Our experience at D-Wave with a number of our customers is it's typically a very small quantum team. If we do a professional services engagement with another company, we usually work with 3 to 5 people at the most. So it doesn't take a great big team, I guess. One of the things I also wanted to share with everybody is ways that D-Wave helps or enables you to build your own internal capability. So if you go to our website, you'll see where we have code examples, we have interactive real-world demos, we have system and software documentation, we offer a training class, we also have free training webinars, we have getting started guides, customer case studies. There are also a significant number of artifacts out there to help you get started and educated that are donated by others not in D-Wave, but part of kind of the D-Wave ecosystem, if you will, where people publish their own papers and demos and code samples for the benefit of the community. So just so you know, that's out there to help you. I'll also talk just for a minute about within the D-Wave professional services group, how we build the capability in people that we hire. And I mentioned for quantum annealing at D-Wave, we don't lean on physicists maybe as much as you would for, certainly not as much as you would for Gate, and maybe not as much as you would at a different company. Remember that 70% or a significant percentage of our company is the people who built the quantum products, right? So our PS team has the benefit of having other people to turn to in the company when they have questions about the physics or the more technical aspects. So our professional services team is solely focused on, or largely focused on, being able to represent the problem accurately with the math. So again, it's optimization engineers, operations research people. But when somebody joins the PS team, we assign them a mentor And then we have them pick, between them and their mentor, a real world problem. And we have them go off and solve it using multiple of our tools if they can. And then we have them come back to their peer group, the rest of the professional services, and present their results. So it's, I guess, maybe trivial or basic. How do you learn any skill? You go out and you do it. I think to accelerate the learning, we pair them with a mentor who's been through it and who knows some good tips. And I think that's another point I would like to share with everybody is that we've had companies come to us and say, we've represented our problem and we've been working on it for the last 6 months and we've used D-Wave to solve it and we didn't get an answer that we were expecting. It wasn't as good as we expected or it's different than we expected. Can you help us, right? And we have some people from our PS team look at those problems and within a week, within a month, sometimes within a day, we can say, oh, if you represented that problem this way, if you change the constraints this way, you would get a better result. And my advice to you is if you're going to start your quantum journey, you don't have to go for 6 months without asking for help. D-Wave can help you. There's partners in this room who can help you. There's people in academia who can help you. As with learning anything, early and often go to an expert and get the help you need. So I think at the end of the day, what we're all trying to constitute is a team that can identify problems that are at the intersection of solvable on the quantum computer and worthwhile to solve on the quantum computer, and also deliver business value. We've had customers come to us with problems that weren't necessarily hard enough or right for the quantum computer. We've also had customers come to us with problems that were very difficult, but really have no business value. So when you solve it, you kind of go, oh, you're done. And there's not much value for anybody in that. So again, you're looking for a team that can consistently identify and solve the appropriate problems. And I think the way to build that skill is through practice. So with that, thank you to the panel members for your time. Appreciate it.
Excellent.